Anybody think that looks gross?
Mm-hmm.
All right. What's nice about it though? Can you say anything nice about the port?
They're each,
The bottoms are the same. So all I have to do is put the tops together. But how are you going to do that? This is x minus this whole thing. So what Sheba's talking about is there's understood parentheses whenever you have a big ass division bar. So there's a negative sign that's got to distribute here. So it would be x minus 2x plus 3. So that's effectively what's happening here in reverse. I'm taking the negative back out instead of putting it in. And that's my time. No. And then blah.
But you wouldn't distribute it to the 5?
Oh, no, there's only one negative. It either goes on the top. I could put it on the bottom instead, but then it wouldn't have the same denominator anymore. So I put it on the top. Yes. Well, no. What can I do? That would be the answer. Let me make sure that makes sense. Yeah. You got variables in my fraction. You got fractions in my variable. It's not quite Reese's peanut butter cups, but well. We got chocolate in my peanut butter.
I was thinking more like peas into mashed potatoes.
Peas and mashed potatoes. I could deal with that. Right, peas and carrots. Carrots and peas. There it is. I was like, please
Peas in mashed
get that
potatoes might be a
reference.
capital offense.
Huh?
Peas in mashed potatoes might be a capital offense.
No, you make a little volcano. You put your peas in there.
Like a 3-year-old, Jeff. We're adults
Are you
here.
kidding me?
Are you the type of person
I
that
feel
needs
bad.
to have like all your food separated in a little nice little container?
No, but now I pay taxes and I eat my peas and my mashed potatoes.
I never read that part in my 1044. In my 1040 it says,
I don't like to make a little soup.
now that you're paying taxes, you must not play with your peas. It's like, no, don't take that away from me. Yes. Whoa. Okay, so guys, so you're missing something there. When I ask you like the scientific notation problem number 7, what's kind of missing there, but what I want you to know from me, your answer must always be scientific notation. So number 7 on the practice test, how would you do that problem? What's the symbol in this notation that isn't used anywhere else anymore? The X. It used to mean this is the one notation that brings it back to mean multiplication. There are no variables in this. You guys with me? I always forget to say that, and it's very confusing. But this notation, part of the notation is the X. Sometimes you'll see people do this, but then that gets a little confusing with decimal and shit, you know. So it's just, you know, part of the notation is the times symbol coming back. So how do I do this problem?
2.5 multiplied by 2.
Yeah, 2.5 times 2.
5.
5 times 10 to the, how many 10s do I have?
11.
Negative 11.
Negative 11.
Bam. Done.
So there's no need to put
Done.
0.
No. It's kind of convention. If your problem has a bunch of fractions in it, you want your answer as a fraction. If your problem has a bunch of decimals, you want your answer as decimals. If your problem has a bunch of scientific notations, you want your answer in scientific notation. You kind of live within the world it sets up.
Scientific notation is a lot simpler than that because you don't have to put too many moving parts in that.
Yeah, it gets really gross when you. Is this a very big or a very small number?
Very big.
Uh-oh.
Small, very small.
Very small, all right? It's 0.0000000. I lost count, but it's a lot of zeros, right? And is this one a very big or very small number?
Big.
Kind of big.
Yeah.
So really small times kind of big if I wrote these out and I said, okay, multiply these, I don't know what the hell. I mean, that looks remarkably gross to keep track of all this shit. So scientific notation helps us keep track of the decimal places. This really is kind of like an indication of decimal places. So it's a beautiful way to keep track of this shit. Do you guys understand? Have you guys ever seen, like, how do I multiply these efficiently? You ready? If I move this one over 1, 2, 3, I can move this one back 1, 2, 3, and then I can multiply. They fill each other in. Aw. Sound a little bit weird, though, sorry. Have you guys ever seen that? If I'm borrowing 1,000 from him and putting it to this guy, so he gets 1,000 times bigger. So when I'm multiplying two numbers, if one of them gets 1,000 times bigger and the other one gets 1,000 times smaller, they multiply the same stupid thing. Of course they do. Right? What's 2 times 6? 12. What's twice 2, 4 times half of 6, 3? What's 4 times 3? 12, because I made them both the same amount bigger and smaller. So of course it's going to come out to be the same thing. That's all that is. But that's easy. This one, it's easier if I look at it just straight up in scientific notation. I don't want to kind of keep track. No, I'd rather do this. That was just for me. I like that. Yes. Oh, that one. All right. So in the book, there's a few problems like this. What's that one say? 7.1 times 10 to the negative 2. 2.4. Negative 4. Okay. So can you tell me what's the 10's going to be? Negative 6. Right? Now to do these, you can just do that in the calculator. That just feels a little bit like you're cheating a little bit. I don't care. Right? Or you can do it a long way. If you do this in the calculator, what do you get? 16.8, 17.04?
Yeah.
Ah!
Got one more 10.
Ah, good. Is that in scientific notation? No. Why?
One more 10.
Because the 17.04.
Yeah, the decimal's in the wrong place, right? This wants it to go which way?
Left.
How many times?
1.
6 times.
Here.
So if I move it back once, now how many times does he still have to go?
One more 5.
5. Not one more time, one less time, because I moved it the way he wants to go. If I got to pick this block up and go 6 steps over, and you pick it up and move it 1 step over, I've only got 5 steps left to go. Thank you. Why not? Can you just keep going? No? Does that? Now, if you don't like that, if I change this into scientific notation, it would be 1.704 times 10 to the 1 times 10 to the negative 6, and that's still freaking negative 5. I mean, so either way you look at it, it's weird that I prefer a less mathematical way. I prefer the picking a block up and moving it, right? That's why I like some of my physics teachers like, do you like math, Jeff? Yeah, what are you talking about? Because I would do problems a different way than mathematically, and they go, I don't know about this kid.
Did you get the answer right?
I got the freaking right answer. I'll never forget this guy. Dr. Hoy. I loved it. Hoy! And anyway, he didn't really appreciate some of my approaches, but I won't.
You're making yourself hard.
I'm a teacher now.
I bet it isn't.
So we need to write first in decimal in scientific notation.
2 ways you could do it. You could either just reason out where it would be, or you could rewrite this.
No, the answer said write it in decimal form.
Oh, okay. In that case, it's easier. Then you just move the decimal back 6 places and you're done.
Without writing.
Yeah.
in-
So I didn't know what the instructions said. If they say
Without
put it in
writing-
decimal form,
Yeah, without writing the.
yeah, exactly. You can go straight, move this back 6 places.
That's
Oh yeah, it is time. Yeah. I probably should give you the answer. You gotta excuse me. I'm gonna lose track of time. first. Well, you might want me to put it in the computer, give you credit. Hold on. Can you put your name on it and then put it back up here? Huh? Yes. No, I'll be in there. I got a meeting this afternoon, so.
We learned this. The book, they are just square this one. So
Well, good.
that's-
Show me that. Show me what you're using.
so,
You can show me the method you're using. So if you want to use the book method, show me that you're doing that.
So what
So
about
square
this
it,
one?
double the middle. Yeah.
Because this is the square and mine is. It's clear.
I know. You're fine, you're fine. Just do a couple of them, I'll leave you alone. It's just in general, I need to see work from everybody, so I know that it's coming from the right place.
So now I'm missing this one?
What do you mean?
I'm just missing one?
Yeah, that one's correction, so I just need to do a few of these. Show me a little bit of work. Or don't, it's up to you.
No.
Okay.
Hey Jeff,
Yeah.
so you're, with this problem right here, you're adding the exponents, right? Because you're multiplying.
Oh, yeah, definitely.
So I thought that would be positive 2 then.
No,
Negative 2,
plus -4.
oh.
You
So
don't-
you're not changing the signs.
No, never. No. I'm not. I can't. Whatever they are, I add them. So it's -2 plus -4, -6. Yeah.
Okay.
Because you can't change the 10, because then that would be.
If it was on the top of 10 to the -4, right? Then the sign would